Okay, so we're off to discuss the second half of our look at perpendicular bisectors and chords. So I'm sitting up here in the corner. I'm going to go ahead and pull my foot down there in the bottom. The theorem that we have going on here, there's one theorem and its converse, and then a second theorem that are all related. And they have to do with the diameter of a circle, and then chords and chords that are perpendicular to that diameter. So the first one says that if you have a diameter and it's perpendicular to a chord, which would mean here, if you notice, that would make it at a right angle, right there. I will go ahead and call this one AB and CD. So if you have a diameter that's perpendicular to a chord, then it bisects this chord, which means that those two halves are equal, and it also would bisect the arc length that's there. So it bisects both the chord itself and the arc length. The opposite of that, of course, is true, the converse of that. In a circle, if you have a diameter that bisects a chord, then it would be perpendicular to that chord. So on my nice little handy dandy card here, dun, 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 you can see that I have it written on there. It's marked as a perpendicular bisector. And the important part that's on there is that if it is perpendicular, then it's a bisector of the chord and the arc. I do need to make sure that you guys clearly see on here. Bisects both the chord length, right, if AB is a diameter, and the arc length. Right, so that we have both of those on there. Then again down here, if AB, which is a segment, is a diameter of those two, then the segments are equal and the two lines are perpendicular to each other. Okay, the second one, like I said, that was the first part of it, and then of course also the converse is true too. So if it bisects the line, then it's perpendicular, and if it is perpendicular, then it bisects the line. Those are super useful when we're solving problems too. Then the second one that we have brought ourselves up to today, it talks about the centers and those bisectors again. If you have a diameter and it is a perpendicular bisector of a chord, so that means that it's both perpendicular and bisected that chord, somewhere along this line will be the center point of the circle. So on this one, if AB is a perpendicular bisector to that chord CD, and then we can go ahead and call this chord CD, and this of course is line AB. So if this diameter bisects, or if this chord bisects the other chord, then along this line AB must be the center of our circle. So if you look at it in the short one, I titled it centers so that we have it in there, and you can see that if AB is a perpendicular bisector of CD, then AB contains the center of the circle. Okay, my joke is an old one. You've seen it before in another video. You can go ahead from here and finish up the rest of 12-2.